Hi everyone, so in this video I'm going to be looking at using the Casio CG50 to help work through or check answers for the Corbett Maths booklet Trigonometric Graphs. So it's the first time we've done a video on anything that's to do with trigonometric graphs, or trig graphs I'm going to call them for short. So question number one, firstly turn it on. Now here we can see that all of my graphs are quite full, and that's fine, I can keep deleting as I go. But if you find that there's a lot going on there, you can go Menu, System, and in here, under Reset, you can clear the main memory. So, main memory, yes, Exit, Menu, and I can go back up into Graphs and see that that is empty. But you've got to be careful with that because that clears everything that you've stored in there. It also sets it back to factory settings. So if you do that, always make sure you go around, you turn the derivative on and the angle to degrees. Those are the only two things you really need to do for the majority of what we're going to do for GCSE. So back to Menu and 5. Here we go. It's nice and clean. I can start a new set of graph booklets. So I've got sine x, lovely, and I'm going to draw that. Oh, but it doesn't look anything like I'd expect a sine curve to. So if you go to View Window and you go Trig, there we go, and Draw, it automatically changes your scale for you. But that's a lot more than what we need on there. So on your View Window, you can set your X minimum to 0, your maximum to 360, your Y minimum to -1, and maximum to 1. Actually, might leave it as -1.6 is what they had, or if you want -1.5 if it feels tidier. So there you go, Exit, Draw. So that's what we want it to look like. Okay, so here we go. It wants us to sketch that graph. Few important points when doing trig graphs. Remember, you can go Menu, Table, and set your table to start at 0, go up to 360, and go up in steps of, say, what, 45? See our table, Exit, set our table, start at 0, end at 360, and go up in steps of 45. There we go, that's the gradient at any point, and these give you individual points to plot. So you can do that one, by all means. But my preferred way, when I'm used to drawing trig graphs, there we go, it's remembered that, is that's at 0, at 90 it's at its maximum 1, 180 is back to 0, 270 is at -1, and 360 is 0 again. And this is my sine curve. So it goes up to there, goes back down through. Lots of practice. You really do get quite used to this. It becomes very familiar shape to sketch. As you can see, that's kind of all you need. Underneath, it wants exactly the same for cos x. So I can go Exit and select, go underneath, cos x, and draw that on the same axes that I've set up. This time, 1, 0, -1, 0, 1. And I know that because I'm familiar with it. Remember, if you don't, you can go Trace, and you can say, what's the value at 180? -1. So you can trace each of those points as you go. Trace, what's the value at 90? It'll plot you that point for you, and then you can do that with any of the points in between as well. Okay, so if you want to know what it is here at 360, there we go, 1 is back at 360, and there's your coordinates. So as I always do, here we go. Now remember, you might be tempted to almost make that a triangle, but it's not. That's why this calculator is helpful. This is a maximum. It's going down to a minimum. is coming back up to a maximum. There we go. And if you want, you can plot the points in between at 45 degrees, as we showed in our table. Next one is tan. So for the tan curve, menu, exit and select. We want tan, X, done, draw. It's already set up. Now what you have on the tan curve is here, if I zoom out, and I zoom out again, you can see it's disconnected. So let's zoom back in again. Where is that? The disconnects are at 90 and 270. They are actually every 180 degrees, and those disconnects are asymptotes. I mentioned that when we were doing the exponential graphs booklet. Asymptotes are where there's no solution. So you draw that here, and you could say, if you wanted to, you could say that, no, we'll just keep the asymptotes in. It doesn't need to be any more than that. And then what are we going to do in between? Well, let's go. Firstly, you might want to tidy that up a bit. So what you can do with that, because that goes all the way up to 450. Let's zoom back in again. That's what it was originally. And so here we go. That's the shape of our curve. Let's look for some points in between. So menu, table, unselect, unselect. I just want that one. So let's set my table 0 to 360 in steps of 45. Let's see if that gives us enough information. So let's draw the table. At 0, it is 0. At 45, which would be here, it is 1. So what we might prefer on this one is setting my table is to go up in steps of 30. That would work better with the scale here. Exit. Now at 30, 0.5, 1.7, and then error. So this scale here, you might want to go up in. You could have this as 1, 2, -1, -2. So at 30 degrees, it's 0.5. So let's just label that 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. This one takes a little bit longer to get your head around the shape, but once you've got it, it's really, really good to know. So it's 30 degrees, it's a little bit more than 0.5. At 60 is 1.2467. 90, there's an error. That's our asymptote. At 120, it's -1.7 now. So -1.2467. 150 is -0.6246, it's just under there. And then 180 is back to 0. And then 210 is 0.6 again. So you can see there is a type of pattern emerging here. So you're plotting 240 is 1.7, 1.2467. Plotting the same points, positive, negative, as we go along. So we're back down to -1.7 again, here. Then pretty much -0.6, here, 0, and there we go. So what would that look like? Well, we have an asymptote. So let's go back, menu, 5. What did our graph look like? Like this. Okay, so here it would go like so, and then it would be the same down here. and then it would be the same down here. And that is your time curve. Question number 4. Shown is part of the curve y equals sine x. Well, we just so happen to have that one here already. So if I select it and I draw it, there's my sine curve. It wants to know there. Now G-solve, that looks like a maximum to me. Maximum is at 91. So that is at 91. B is my minimum. So G-solve, minimum, 270, -1. So I can put that on here, 91, 270, -1. For the cosine curve here, if I go exit and select my cosine curve, that is where G-solve, I want to find out what the root would be. The root is where it crosses the x-axis, its solution. So here, 90, 0. B is my minimum again, and that's at 180, -1. It's just so helpful to have these sketches already done. Here it says one solution of sine x is -0.5 is 210, and then it wants the other solution. So what we can actually draw here is I want to see what happens if, now let's have a look. I want the sine curve here, and I'm going to also draw the line y equals -0.5. Draw. So there I have my sine curve, and there I have my line y equals 0.5 or -0.5, because if I have y equals sine x, y equals -0.5, sine x equals -0.5 is where these two meet. Simultaneous equation. So I'm going to do that graphically. On G-solve, I want to know where they intersect. We haven't done this one, I don't think, before. They intersect at 210, -0.5. That's right there. So at 210, it's -0.5, like this. You could even sketch it on here. And then our other solution, if I scroll to the right, is at 330, -0.5. Okay, so that one there then is 330 for that solution there. So x equals 330. So that's a really handy thing to know. Here, cos x is 0.5, same as before. -0.5, same as before. -0.75, same as before. Draw each of the lines here, just to remind you, want y equals cos x, and you want to know where that meets y equals 0.5. You want y equals cos x, and where that meets y equals -0.5, and then y equals cos x, and where that meets y equals -0.75. And it'll do all that for you. And lastly, here we go. One solution is 0.766, it's where x is 40, and then it wants the other solution, and then to use your sketch to work out the value of cos 200. Okay, you can use the symmetry on the sketch, but you can actually draw the graph to the right hand side as well. So there we go. That's the end of me helping you and showing you how to use your Casio FX CG50 to go through the Corbett Maths booklet on trigonometric graphs. Thank you. Bye-bye.